Hello everyone, thank you very much for joining me again in this episode 7 of the Software Architecture Fundamentals series. If you're watching the event live, don't forget you have a live chat there, so you can ask me questions directly in the live chat. If you are watching the event recorded, you can still ask me questions in the comment section or find me on Twitter and LinkedIn, and we can discuss there as well as usual. In this episode, we continue our discussion with service-oriented architectures versus microservices. And what you will see is that actually microservices is nothing else than a more particular way to implement service-oriented architectures applications, as some of you have seen, have observed in the previous episodes when I've started with discussing service-oriented architectures. Someone said, isn't this the same as microservices? Well, it's actually, microservices is a kind of a software-oriented architecture, and that's why many of the things I have already discussed with you is something you will find discussed and described also in materials related to microservices, just because they are basically software-oriented architectures. But now we'll go a little bit more in detail, and we'll see what does a system need, what does a service-oriented architecture need to actually be microservices, and which are some concerns but also advantages you have with this more particular kind of an architecture we call microservices. Yeah, that's the point of today, and from here we'll start on and discuss a lot of more other relevant things, like for example how to deploy them, how to secure them, and so on and so forth, and then relate to software qualities. And you will see we have a lot of things to discuss, as you probably already know if you watched the previous episodes at least. So first of all, I'd like to say that we have services. So they are called microservices because they are services, and they are called micro because it happens that because of one of the constraints we'll discuss, they tend to be small services. But I would like to draw your attention from the very beginning and start by saying that it's not necessarily if you make your services small it means they are microservices. So it's kind of sometimes an illusion that if you want to have microservices, just make them small and that's enough. Of course it happens, because as you will see when we work on microservices, one constraint is that they should have one responsibility, which in most cases, and I would actually say maybe in all cases, it makes that they have a small footprint as well. But that's not the opposite, it doesn't work. So it's like in mathematics when you have a specific law working but not its opposite. Like here is the same thing. If it is a microservice, it is small. If it's small, it's not necessarily a microservice. So that's something you have to keep in mind. So in order for an architecture to actually be microservice, it needs to fulfill some of the things, or at least to fulfill the things we'll discuss today. So let's say I have, so how do I draw a rectangle here that represents my service? Let's say I have some services. One of the things you will see related to microservices is that they keep independent their persistence. So this is a very important thing. That doesn't mean that all the services really need to have a persistence layer. So it might be some of the services don't have a database, but we won't have one big database to which all the services connect. In case of the microservices, one of the relevant aspects of this architectural style is that the applications are totally independent. And when I say totally independent, if they need to keep persistence, they will keep their own persistence. So like in my case here, say the 4 rectangles or squares, whatever they are services. Like in my case, say A, B, C, D. Yeah, distributed transactions, sorry, it's a very relevant subject here, because that's where it starts from. This is why I first start with discussing the separation of the persistence, and then you will see this is one of the concerns, is the data inconsistency, and the fact that now a use case might spread on multiple services, so that will result in the possibility of having inconsistent data in case you have errors. And one of the way to solve that problem is implementing distributed transactions, which I don't really like, as I will explain you further, but it's one of the solutions, and we will discuss that using that what we call the Saga pattern is one of the ways to, this one I don't need, to implement distributed transactions. So A, B, C, D are, in my case, let's call them from now on microservices. So they are not only services, they are microservices. And the second important thing is, again, that when you deal with microservices, the fact that they tend to be small is something that I actually see as a consequence, not as a rule. As I was telling you, because people and developers sometimes confuse it, saying if it's small it's a microservice, which is not necessarily true. But usually if it's a microservice it is small. So the one way it works, the other one it doesn't work. And the reason is it's better to actually say that each service has its own independent responsibility. And I want to really clarify this. When you think about responsibilities, what you actually think of is having sometimes multiple things that work together, but in a such coupled way that they are inseparable one to the other. And I want to stress that, especially because I know all over the web you'll find different articles or materials where the responsibility is described as only one thing, which is not correct. So whenever you'll hear that somebody says a microservice or a class or a method or whatever you refer to does only one thing, so it means it only has one responsibility. This is not the definition of responsibility. So a having only one responsibility, it doesn't mean it does only one thing. The way to define responsibility like that is very tricky, because you will see actually that when we discuss responsibilities, a class, object, method, package, service might do multiple things but still have only one responsibility, but with a condition. Those things should be so coupled that they don't make sense one without the other. And I was giving you, and I will repeat my example to clarify it, to see it better. One of my favorite examples in terms of responsibilities is the password encoder contract from Spring Security. The password encoder contract does two things actually. One of them is the encoding, and one other is the matches. The encoding is the action that transforms an input into an encoded output based on a rule, while the other thing the contract is containing is defining. Is actually declaring, better say, because it's a contract, not an implementation, but of course the contract has then one or more implementations, is matches. And the matches method, it simply tells you if a specific plain text given input relates to a specific encoding. So if indeed the input and the encoding, they match based on that specific algorithm. So indeed the password encoder does two things, but it still has only one responsibility, because you cannot decide a match without knowing how the encoding is done, and you definitely need to not only have the encoding but also a way to match a plain input with an encoding. So you see these both two things, couple of things, they still make only one responsibility. And that's in my experience, one of the most misunderstood things in terms of responsibilities. And that's why I want to make sure when you think about the single responsibility principle, which is a very important principle out of the solid, don't never use the definition it does only one thing, because that's not correct. Of course, if it does only one thing, for sure it has one responsibility, but it's not necessarily that it does only one thing and has one responsibility. That's what I want to stress out of this. And this applies to services as well, because the single responsibility principle is not a principle that you only apply to object in object-oriented programming application. It's not only what you apply to a function in a functional application. Is not only what you apply to a class or to a method, or you can apply it to all of this. It's a principle that applies in general to almost anything in design and architecture, and it applies to services as well. So in the case of a microservice, first of all, you have to make sure it only has one responsibility. Secondly, it manages its own persistence layer, and with the fact that it has only one responsibility, of course the consequence is that the footprint is also smaller, and the fact that it manages its own persistence, this gives us the fact that it's small and it manages its own persistence, so both of them all together give us a lot of opportunities above any other way of implementing software-oriented architectures, and of course above a monolithical approach. And taking it now, let's see which are our opportunities given by the fact that we have a small footprint and they have only one responsibility and they manage independently the persistence layer. First of all, we all like to hear that microservices systems are polyglottic. So what does this actually mean? It means that you have the opportunity to implement a service using a specific technology. And when I say technology, I say platform or language. Like you might have one microservice implemented with Python while another microservice is implemented with Java. Or you might use, for example, Quarkus to implement a microservice, and you can use Spring Boot to implement another microservice, maybe the same language but to different platforms. Or you can use Spring Boot with Kotlin to implement one microservice and Spring Boot with Java to implement another microservice. And this is both, this characteristic comes with both advantages and disadvantages. So don't think about the polyglottic characteristic of a microservices system as being only one good thing, because first of all, let's see, we are optimists, so let's see which is the good thing that comes with a polyglottic characteristic of a microservices system. So one of the things is that it allows you use the perfect match of a technology depending on what the purpose of the microservice is. Because say that microservice A processes data, I don't know, it implements maybe some machine learning or other artificial intelligence algorithm to process data, then you might want to use Python for that. Of course, in that case, most probably Java won't be the right choice. And you can do that, just implement that piece of functionality with precisely the language and the tools you need to do the best out of it. And this is a good thing. So the fact that you can have a perfect match between the responsibility and the technology. So I write it because I find it easier to have it in front of our eyes when we discuss it, and we remember which are the important points we discuss. So one of the one of the good things in terms of the polyglottic characteristic is the fact that you can find the perfect match. You are not forced to use only one technology or only one platform. And no, I'm not talking about monolithic here, I'm talking about microservices. So when we discuss microservices, we say the system is polyglottic, and that allows us to use the perfect technology. Cool. This is a very important thing, because if you use even a normal service-oriented architecture which is not microservices, you might have situations where you share the persistence, and that's something which allows you less flexibility. Because here at the persistence layer, and maybe I should have stressed this too, because now the persistence layer is also part of the microservice itself. That means that at the persistent layer you can apply the same polyglottic approach. So when I said polyglottic here, I didn't only refer to the service itself, but also to the persistence. See, if you have a specific service that works better with a specific NoSQL approach, then you can use that specific NoSQL implementation. Say you have some kind of machine learning algorithm that works very well with a graph-oriented database, then definitely you will have probably something where you choose Python as the language or the platform, and you use Neo4j, say in case of the NoSQL approach, for some reason or another kind of a technology, or you can have some data analysis tool, and then you use R, which is a known tool for data science, and another kind of a specific database that fits well with the responsibility. So you can match precisely the technology with the responsibility. This is one of the good things that comes with the polyglottic approach. Okay, a question that is very interesting is, what about services sharing a database? So theoretically, when we discuss a microservices architecture, you should not have a shared database. So that kind of a shared database applies to a normal service-oriented architecture like the one we discussed in the previous episodes, but when it is a microservice, then the microservice shouldn't share one database. Of course, in the real world out there, you'll very rarely see only clean microservices solutions, so it's better to say that's more when multiple of the systems out there, maybe we can say that they have a mix of, usually they have a monolithic application as well, somewhere hidden, and from that service they extracted some other services, and maybe they have even split the services into microservices that use their own persistence. So it happens very often in real world scenarios that you don't have a perfect match. But when we discuss microservices, they imply that the persistence layer is independent to the service itself. So you can't literally say you have two microservices connected to the same database, because in that case it's just a normal service-oriented architecture system and not a microservices one. So another interesting question, can service-oriented architectures be polyglottic? Yes, they can be. But the advantage with the microservices is that theoretically microservices really mean you have splitted the responsibilities. So you have now the opportunity to have a direct match between the responsibility and the technology. While in case of the service-oriented architectures, so normal SOA, which are not microservices, that doesn't imply a service necessarily has only one responsibility. So you might have services that have only one responsibility, but you might have services where you have multiple responsibilities altogether. It's not a monolithic architecture because you still split it in multiple services the responsibilities, but it is much more difficult to link the responsibility always to a specific technology, because sometimes a service has more responsibilities, so then you still have chances to need to link multiple responsibilities to one technology, even though maybe they would have worked separately with different technologies. But what I do recommend in that case, if you find yourself in such a situation, do extract the responsibility that works better with another technology and put it separately into another service, because somehow a service-oriented architecture that is evolving healthy is usually evolving up to a microservices architecture. So you will see that, or at least that was my feeling. That's just empirical feeling. It's not a research I have done, and I'm not quite sure how could have I done such a research anyway. But from what I read and from my own experience in working with systems, it seems that if the process is healthy, it tends that it converges to microservices, just because it forces you somehow, like I said, answering John's question, when you have such a case, then it somehow forces you to extract the responsibility, and that's how step by step you actually converge to microservices architecture. And then you have, okay, so yes, I think I answered the question correctly. So indeed, I was referring to SOA versus microservices, and I said that it can, but due to the fact that in SOA you might have multiple responsibilities, you have to converge to microservices. Cool. Let me know if you still have questions. So this is really good. This polyglottic characteristic is really good for fitting, because I was actually I'm always reading things and articles about software architecture. I'm listening to different presentations delivered where it's said that it's said that the architecture is completely agnostic from the technology, but in my experience it's a very good mix between technologies, knowing where to put them, and software architecture, because sometimes really some architectural style works better with a technology than another, or some architectural approach, while in some cases a mix of technologies work better with some architectural approach. So with experience you find out that choosing, when you think about the architecture, if you think about the technologies as well, you only then find the perfect match between them. And that's why usually it doesn't only take an architect to solve this problem, but also an experienced developer. Because remember, at the very beginning in the first episode, I was telling you that the architect, even when say the technical architect, remember we discussed there are three main architectural roles. So we have the technical architect, the solutions architect, and the enterprise architect. When discussing the technical architect, this is not like a second level Pokemon of the developer. So it's not like a developer evolves to an architect and now it becomes better and you say always the architect is above a developer. The reality is that an experienced developer is on the same line with an experienced architect, just that the architecture is seeing everything from the top of the mountain, while the development means going in depth into a specific technology. So in case of the developer is the one that sees not a larger spectrum of technologies, but those they see them in depth, while the architect doesn't always see in depth, but it has a very, very large view, a very large picture from above, and knows a lot of technologies and how can assemble them to put them together. And sometimes at least when you have a difficult project, a good mix with a senior developer and a senior architect gives you both the big picture and the in-depth, which helps you make the right choices in terms of the architectural and class design decisions and application design decisions for that system. So that's how you should see the things. And if some of you will ever manage a project, like from a project management perspective. Always think about that when you choose your team. If you have to choose a team, remember that an architect usually knows stuff from the top of the mountain, but not necessarily in depth, and a good developer knows them in depth. They always make a good match, and in a complex project you always want that. So another question is, decomposing service into microservices can be considered to balance the load apart from adding more instances of specific service as long as we stick with single responsibility principle. First of all, I'm not sure if I understood correctly the question, because I don't see a relationship between extracting the responsibility. I actually even see more instances at some point. And that is a good thing, but I will characterize it as a concern of the microservices, is that now you actually, the management of the deployment becomes even more complex because you have more instances. So you might say, and maybe what you are saying is that I have two responsibilities, one of them doesn't necessarily need to be scaled because it's less important. So we can have simply a circuit breaker, as we discussed in one of the previous episodes, and say, well, if that one isn't working, then my circuit breaker will take care of that until it's up and running again. But at the same time, in the service you have a responsibility that needs scaling, and then you take it out just to make sure that you scale only what you need to scale. And then if that was the question, Temir, then my answer is yes. In that case, microservices help you indeed horizontally scale only what's needed to be horizontally scaled, because indeed sometimes you make the compromise of having a service that's not horizontally scaled because you don't want to spare the resources to horizontally scale it because it's not that relevant, and maybe you already implemented a circuit breaker, which, remember, it was that pattern in which in case a specific server is down, we have an alternative for it. So the circuit breaker closes and you go to a specific other service. You can do that compromise, and in that case it allows you scale only what it's needed, because some of these services, they don't need to be scaled, and to choose which one needs and which one doesn't need to be scaled, of course this is a decision based on literally the system you implement, because you only by knowing the business you implement, you know what you need and what you don't need to scale. And then we have another question: do microservices use domain-driven design? Domain-driven design is a way to find the boundaries in designing a service-oriented architecture. We usually use domain-driven design to find out how to implement the system, but because it's a separate subject, I will treat DDD, domain-driven design, in the next episode. But to now fast answer you, yes, you can use DDD when implementing microservices. Or for finding out, maybe it's better to say, which are the microservices boundary and how to implement them. Cool. So, and now we were discussing the awesomeness of polyglottic, but what is a bad? So this is a plus actually. So I say plus here. Plus means is nice. Minus means is not that nice. What is a minus of having polyglottic characteristics? So this is also now the fact that you might end up literally with a dozen of technologies in a system, which makes it very difficult to manage by a team, because take into consideration the fact that each service is not necessarily managed by one team. You might have teams that manage multiple services, and if you end up with many technologies, then you will either need very skilled developers to know all of them, and trust me, in my experience, it seems that having so skilled developers in only two different technologies is very difficult to find. So when we say full stack developer, in my experience, maybe I'm wrong, I might be wrong in everything I say, but it's very difficult to say that I'm an expert in both Spring Boot and backend Java solutions, and Angular, React, and Vue. So it might be that I know how to code in both of them, and for example I know how to code both front-end and back-end and database, but that's not enough, because being an expert, it gives you all the insights you need to know so that when you take a decision of an implementation, you don't take it wrong, and in a couple of years from now on it needs to be rewritten because it wasn't taken okay from the very beginning of starting the application. And the same is with having multiple approaches. So say you are using Java in one system, and one of them is actually implemented with Quarkus, the other one uses Spring Boot. You also found it nice to use I don't know, Microprofile or Micronaut in one of the services. Then you have another service using Python technologies, and you even have one more service, I don't know, using .NET technologies. So now you already have a problem in terms of managing your team, because you will, if someone leaves, then you might find it more difficult to find a replacement. And when you think about software, everything is important. It's not only the technologies that you choose, it's not only the way applications interact and the architectural style. You have to think about the team, you have to think about the process. Are you using agile or a waterfall approach? What kind of agile approach methodology are you using, and so on and so forth. And they are strongly related one to the other. And I at some point some years ago even delivered some presentations on how are these all related one to the other, and why a software architect should have all of them, should know all of them. When you take advantage of the polyglottic characteristic of a microservices system, always take it with the head on your shoulders, meaning that don't choose a technology just because you find it, I don't know, fashionable, just because you think it's nice, and choose it when it really solves a problem, a concern you have. So say you have, again, going back, you have some data you want to implement some data analysis on, then you probably choose Python, and you take an advantage of the polyglottic characteristic then, because you won't be able probably to achieve the same thing with Java or Java technology, or you can achieve it, but it's much more difficult to do that. So you choose Python instead because it gives you more opportunities, and that's a good thing. That's an example of taking advantage. But then if you have a Java developers team, and when you choose to use Python, then you already need to have one more member in the team knowing also how to code Python. But then if you start just choosing different technologies for of your services without having a good purpose, you will end up with more more complexity, because suddenly only, and that's even if some developer knows how to say use Quarkus and Spring Boot at the same time, changing contexts is something difficult for anyone. And I'm not referring here to programming, I'm referring to changing context in general. Changing context like I'm doing something now, I'm cooking something, and then suddenly I have to do something else at the same time, or come back to one action from another one. When it's not programming, most of the people, maybe not all of them, but most of the people find changing contexts difficult in general. So that changing context in programming, it's even more difficult. So the less you have to change in terms of the context, if you don't have to change the way of thinking from going to one microservice to another, then the better is for the performance of your team. So trust me, that's something that's something that has been proven. So the idea of the polyglottic characteristic of the microservice is taking advantage of it rather than over-engineering your system. And the easiest way to over-engineer your system, I found in my experience, is developers always wanting to try something new, which I do it myself. I always like to try something new. Did some new technology appear, I really want to try it and see how it works. Now, Spring Native just appeared. Of course, I was one of the first putting my fingers and trying it, because that's how most of the developers work. But between using it for learning and actually putting it in a production system, it's a gap where you should literally very well think before taking a decision. So is, for example, Spring Native something that I will now choose to use straightforward? Most probably not yet, or at least when I do that, I think about maybe using a proof of concept first. I'm thinking, does it really bring me advantage? What is the advantage? How much advantage? Because the advantage should be more valuable than the cost. Because if the cost of implementing a specific microservice now with Spring Native is higher than the advantage, that the speed, basically that's what Spring Native mostly gets me, then I might choose not to use it, not because it's not an awesome technology, but because it doesn't now bring value in the system. And that's something you need to think of as an architect when you choose technologies. One of the many things you need to think about. So the say possibility to now over-engineer the system. This is something you need to take into consideration, and always choosing a technology. And I've seen that. I've seen this problem in projects where developers just, for some reason, they chose Scala before thinking if it really brings any advantage. And they ended up with some Scala microservices, and now those teams found it very difficult to maintain it, because now they suddenly have to bring developers that know both Java and Scala, or have separate developers that know only Scala. Usually one who knows Scala knows Java as well, but not necessarily the other way around. If you know Java, you don't necessarily know Scala. For example, I know a little bit of Scala, but I can't consider myself an expert in Scala. So it brings now more disadvantage in the way of the team and how it's managed. So don't over-engineer your system. Take advantage of the characteristics of microservices, and that's without over-engineering it. Now, what other characteristic is what other thing we need to know about microservices, say in general, is that having the persistence independent, of course, we already discussed, it also brings us the possibility to have it also polyglottic. So say one service uses Neo4j, another one uses MongoDB, and another one uses MySQL for some reason. And it might be that we have microservices that don't use any of this because they don't need a persistence layer. But you also now have the situation where if you implement a use case where multiple services interact to use it, to solve that case, so the services interact over the network, as we discussed up to now in the previous episodes for the service-oriented architecture. So when you implement an SOA, either if it is or not a microservice, then you have this case where to implement a specific use case, the services need to communicate over the network. And now what is the problem is that you might have changes in multiple databases for one case. And that wasn't actually an issue when you had it only in one app, just because you it was really easy to implement it, the use case transactional. Remember that when you implement some use case, you simply just say, if you are working with Spring, you add the add transactional annotation, and you know that behind the scenes Spring makes sure that method is wrapped in a transaction. So if some exception occurs, then you your transaction will roll back and all the data that have been changed are no longer there, so the data is kept consistent. But that's more difficult to do when you have microservices, because now say you have A calling B, say it's just A calling B for a specific use case, and say A does something, it calls B, B changes the database, so changes some records, adds, modifies, deletes, whatever you want it to do. It changes data into its own database, and then it returns, and then something happens and A fails with an exception. Well, this is a problem because now it's way more difficult to undo the changes that B did in its own database. So well, I will show you some ways to implement to make sure that you have consistent data in the end, but it's not the easiest thing you can do. So usually what developers do is avoid as much as possible having use cases across multiple boundaries like this one here, or simply implement only those use cases where creating such data inconsistencies is not a problem, because now we discuss only about two services, but you will see that if you have one more here, say B also depends on C, then it's even more difficult to implement that. And in this case, when you have more than two services, it's something that I don't even recommend implementing it with a REST approach. In this case, it's better that you use a reactive approach with messaging queues, where you have each of the service confirming the fact that everything went well, and all the data being committed only when all the services confirmed that they correctly executed their task. And that's what we call a distributed transaction. So that's one of the ways you can implement it, is when you have such a case where multiple services, microservices in this case, communicate one to the other and change data in the database. Each of them confirms that they successfully ended what they need to end, and only when all of them successfully confirm, then all of them can commit the transaction and make the changes. Yes, this is basically what we call the Saga pattern. In the way I like to describe it, because I tried to search some good explanation on how that works, but I didn't actually find something that's easy to understand. Well, honestly, that's not actually easy to understand. How can they confirm? They can easily confirm by, say, placing a message into a message queue once they finished what they had to do. So in the end, when you know a specific use case is done by three services, let's call them three actors, and all of them confirmed, like they added an acknowledge message into a specific queue, then all of them see that the others confirmed, then they commit the transaction. So something like that. I hope I was clean enough in my explanation, because I know it's not an easy thing to understand, and trust me, it's even a more difficult thing to implement when you have such an implementation. So that's why, as I said, usually avoiding the need for distributed transaction is better than implementing the distributed transaction, or at least this is my feeling now with my experience. So yes, this is another. Now they are small. They are even usually the smallest way you can go, because smaller than this, smaller than a microservice, it's only having serverless functions, which we'll discuss later in a next episode. And the serverless function, they are, let's take them separately because they are different. But when you say microservices, you say I've reached a point where I know my services have only one responsibility each. So it's the minimum footprint you can get in terms of implementing them. So in this case, we can say that first of all is the most granular way. So the high granularity is another characteristic I would like to mention here. And again, like the polyglottic characteristic, the high granularity has also advantages and disadvantages. So of course, the advantage is pretty clear. So when you deploy now, you really are able to deploy only one responsibility. So that's basically, you can literally go with only one responsibility that changed into production. And sometimes if other responsibilities are affected by the one you changed, then with those as well. But it's still the easiest way to manage the only domain you need to redeploy for a specific change. However, what happens is that microservices might become very such a microservice might have a very high number or a very large number of microservices, and then overall it becomes more difficult to understand how they interact one to the other. So that's why in specific we have specific infrastructure related ways to see how the services interact one to the other. And again, I was talking about last time about a service mesh, which again is one of the things I will discuss in the next episode. A service mesh such as Istio, for example, gives you the possibility to implement a map of communication. There are also different ways to keep and see the way microservices communicate, like Jagger, for example, or Jagger, I'm not sure how to pronounce that, is a technology that you can use to trace the communication between microservices, and creating a nice map on how on a specific use case services communicate one to the other is very helpful when trying to debug and identify issues. It tells you if a specific service didn't respond, maybe if a specific service was called because of a specific circuit breaker, maybe if for a specific service we needed to do multiple retries, and so on and so forth. So that really adds, this high granularity adds a lot of complexity to debugging, and to get over this complexity, to solve it, we needed to find different other solutions to trace it. Okay, if there is a two-phase commit protocol also, and if I'm not wrong, this is a blocking one. This is a two-phase. There is a two-phase. I'm not sure. Is it a question or is it a statement? On this one, this time I'm not sure if I understood if it's a question or statement. What I was discussing earlier, it's something like a two-phase commit, but it's at the system level, not at the service level. And then, is there any other service which manages the communication? Also, I'm not sure what you mean by any other service which manages the communication. So you might have, and you will most likely have, a gateway, as we discussed in the previous episode. You might have, for example, service discovery, which can be a client-based service discovery, or service side, as we discussed in the previous episode. But I wasn't discussing about that right now. I'm just focusing now on the microservices itself as an architectural style. Then we have Microservices Patterns of Chris Richardson. Yes, I do recommend that one too. I have it from many publications. I actually have a lot of books, of their books, because I'm also an author with them. So so I do happen to read a lot of their books as well. And yes, I do recommend the Microservices Patterns. Okay. Okay, so it was a statement, not a question. Okay, thank you very much. Cool. Now, so the high granularity, and I didn't state it here, but again, we have pros and cons, and I discussed them already. And what I was saying is that one of the one of the plus is that you can actually scale easy. Then you have another plus where we said that you can replace only what changed. And then we also have the minus, that the debugging becomes more difficult. And you need solutions like tracing the requests between microservices. And then of course the orchestration itself is more difficult, and by orchestration I mean deploying and taking care of the deployment in the whole system, and that's where we have now orchestrations tools that are very often encountered, like Kubernetes, that help us minimize the amount of work we had to do to deploy the microservices in a specific environment. Okay, so as you see, is not when we discussed already a lot of things in terms of service-oriented architecture. So now I don't necessarily have to rediscuss all of them, because what we already discussed in terms of SOAs, they apply to microservices as well. So we know now from the previous episodes that the communication is done throughout the network. We know that means, and remember, the network is never 100% reliable. So all the concerns, but also all the solutions that we discussed in the previous episodes, I want to state that you can apply them as well here. So I focus today only on what's different in terms of microservices in regards to on the other hand by a monolithic and another, say, SOA architecture. Another more questions continue to come. So when you use cloud providers, we give up at some microservice patterns like config Eureka server in Cube, for example. So when you use when you use any kind of this infrastructure, when I say cloud providers, in my mind it's also private but also public clouds. I want to stress it because some people, when you say cloud, they directly think about Amazon Web Services or Azure, which is not necessarily the case. And again, this is a topic I will discuss in the next episode, where I will take private versus public clouds. Now, whether it's a private or a public cloud, because it doesn't really matter, we sometimes say give up at Eureka, which is a client-side service discovery, just because you can do it differently, like through a service in your Kubernetes infrastructure or your OpenShift infrastructure. But you will definitely have a service discovery, because without a service discovery, I would actually say it's impossible to deploy microservices, and I would go even further and say, in general, service-oriented architectures, whether they are or not microservices, it's still difficult to work with them without service discovery. So service discovery Whether it is client-side or server-side, as we discussed in the previous episode, you still need it when you have a service-oriented architecture, whether it is or not microservices. Now, because there are multiple ways in which you implement that, sometimes it's more transparent, more transparent than in other cases, but you still need it. So I don't see a way in which you can avoid that. So I will discuss, if you are really interested about the microservices patterns, I will actually try to take them in one of the next episodes, because my purpose of today's episode was not to discuss, as you have seen, patterns now. I was discussing the main characteristics, which I find them very relevant to know before going into patterns. I always see people, sometimes they are very impatient and they go, just directly trying to understand the more difficult stuff prior to understanding the overall picture, or the more easy things. And I see that also, for example, with my book Spring Security in Action, where people still try to ask me questions and they say, I don't understand how that authorization server works or that resource server works in chapter 13. And then I'm asking them, did you actually read chapters 1 to 12? And they say, no. Well, chapter 13, it relies on 1 to 12, so if you don't know those, you don't understand 13. So my plan for what I wanted to say is that my plan for today was to make sure that I introduce you the microservices, so make sure that you know what they are before going deeper into the subject. And then probably one of the best things to discuss later is some patterns, some architectural patterns for microservices, and of course then how they affect different software qualities like scalability, security, maintainability, and so on. I think I have time to take more questions. So when we choose Spring Cloud or Kubernetes, why choose between them? From your question, I understand that you want to choose between Spring Cloud or Kubernetes. Maybe I'm wrong, but that's not something you need to choose from. I mean, or maybe you are thinking about only the service discovery. Your question is not complete, so I don't know how to answer. But it's not a choice. I mean, there are two different things. It's like, when do I choose between buying a car and buying a kilogram of apples? It's totally two different things. You can choose between them. It's not something I can answer. So if you're actually referring to service discovery and you're referring to Eureka, if I remember correctly, and I think I've shown you this in the previous episodes, Eureka is actually deprecated. So you anyway don't have a lot of choices there actually. And in terms of implementing service discovery, also, as I told you, I think in the previous episodes, my opinion is going to a server side rather than a client side service discovery is more transparent and more and easier to understand from and separate the responsibilities and at some point between infrastructure and development. So I would go to using a server-side service discovery rather than a client-side one usually. And with this being said, I see we don't have plenty of time still, but I hope with this lesson I at least given you better picture of how microservices work and what they are, and that gives us a lot of opportunities further to discuss a little bit more on some patterns that apply to service-oriented architectures and microservices. Sometimes be aware that the same things we discuss for microservices, they work with mixed architectures and with service-oriented architectures as well. Yeah, we are again good to go further and discuss now more complex solutions. One more question I can take from you on how many microservices is okay to have in the same project. No idea. So I've seen projects with 20, but I've also heard about projects with thousands. The more you have, the more difficult it is to manage them. We have solutions now, and usually when you have hundreds of microservices, not all of them relate to the other, fortunately, if you correctly identify the domain. So you might have, and you for sure will have, different teams managing different domains. But I don't think that anyone actually discovered a proper number of microservices, and I'm not even sure if I could say there is one. I'm not afraid to say that you might have many microservices and still have a manageable system if it was correctly implemented. So at the moment, from my perspective, I would say that sky is the limit. Maybe I'm wrong, maybe in the future I'll discover this is not the case, but for the moment this is what I can say. Yeah, there are actually implementations that have hundreds and maybe over 1,000 microservices for big companies. I won't name now, but big companies I have seen. Yeah, but basically I think this is it, and we covered the topic for today. Hopefully you liked it and you'll be back again. I see more and more people joining the stream, so thank you very much for being here with me, for asking all these questions. I think it's one of the best streams I had in terms of people interaction. Let's deal together first in the next episodes with a lot of other juicy subjects for software architecture fundamentals. And up to next time when we meet, thank you very much again, and have a great time for study further. Cheers, bye bye.